My name is Craig Foley, and I'm the CEO of Hospitality Newfoundland and Labrador. We're very pleased that you could all join us today, and we're looking forward to some great discussion. Before we get started, I guess just a few housekeeping notes. The chat window is there. I know Greg has found it, a great way to communicate. This is a webinar, so we're not able to use the mic, so you need to post your comments in the question and answer. Post your questions in the question and answer box, or again, use the chat just to communicate. And our presenter today will take breaks at certain parts during the presentation, and we'll invite your questions then, or at least address them. I want to respectfully acknowledge the province of Newfoundland and Labrador as the ancestral homelands of many diverse populations of Indigenous people who've contributed to 9,000 years of history, including the Beothuk on the island of Newfoundland. Today, this province is home to diverse populations of Indigenous and other people. We also acknowledge with respect the diverse histories and cultures of the Mi'kmaq, Innu, and Inuit. I would like to now thank our partners and collaborators and the ones who've really supported this initiative, Natural Resources Canada, the Department of Environment and Climate Change, and the Department of Tourism, Culture, Arts, and Recreation. We're very happy to have Lindsay Allen with us today. Lindsay is a climate resilience engineer with CBCL Limited and is registered as a professional engineer in the province of Newfoundland and Labrador. Lindsay specializes in climate change risk assessment, adaptation planning, supporting a wide variety of sectors, including municipal asset management, private industry, infrastructure design, and natural resource management, among others. Lindsay's risk assessment work involves analyzing climate change projections against design, operations, regulatory practices, and the natural environment to identify potential impact from climate change and to develop adaptation solutions. She also has extensive experience in facilitating stakeholder engagement workshops and consultation sessions in order to incorporate local perspective and expertise into risk assessment and adaptation planning. Climate is an extremely important issue that will have an impact on tourism operators. Hospitality Newfoundland and Labrador, the provincial and federal governments, have recognized that to ensure that the industry remains sustainable in the long term, tourism businesses and organizations must be able to identify risks to their business to effectively plan for adaptation. Climate change is impacting Newfoundland and Labrador's land, ocean, and related ecosystems. Tourism businesses that heavily rely on these ecosystems won't be able to operate in the same way over the coming years due to changes in the operating conditions of these ecosystems. Hospitality NL is doing a three-part series on climate change and its impact on various tourism sectors. Today's session will focus on the impact on marine-based tourism, and Lindsay will inform us of some of the challenges facing this sector and the opportunities for adapting to prepare for the future. Without further ado, Lindsay, welcome.
Thank you very much, Craig. And thank you to Hospitality Newfoundland and Labrador for hosting me today. So like Craig said, I'm here today to talk to you about some of the climate change adaptation work and some of the risk assessment work that we've been doing here at CBCL with Hospitality Newfoundland and Labrador. We've been doing some of this work over the last year or so. So there's lots of great information that we've collected and information that we can share with you today. So I'll just dive right into some of the things we're going to talk about. So Craig already mentioned this, but first of all, I'd just like to acknowledge the Department of Environment and Climate Change with the province, as well as Natural Resources Canada, who both funded this project. Both organizations are doing lots of great work related to climate change. So thank you to them for making this possible. So again, Craig's already said some of this a little bit, but basically climate change projections for Newfoundland and Labrador show significant changes by mid-century and beyond. And it is, of course, important to enhance our understanding of the impacts on the tourism industry and take the appropriate measures to ensure the industry remains resilient in the face of climate change. And that is really the whole root of this project. And the work we've been doing is to make sure that our industry, the marine tourism industry specifically, remains resilient to climate change. So before we jump in, I'd just like to highlight the difference between climate change adaptation and climate change mitigation. This might be obvious to some, I'm not sure, but it tends to get confused. So just to make the distinction, climate change adaptation, that's what we're talking about today. So basically, climate change adaptation is activities that lessen the negative impacts of climate change. So this includes actions taken before impacts are observed, as well as after impacts have been felt. So that's things like upgrading infrastructure or processes or plans to account for climate change that we know is happening or that we're already experiencing. Whereas climate change mitigation is actions to limit the magnitude and or rate of long-term climate change, generally involving efforts to reduce human emissions of greenhouse gases. So any sort of carbon sequestration projects or renewable energy projects that sort of lessen greenhouse gases. That's what we're referring to when we talk about climate change mitigation. But for the purposes of today and this presentation and this work we've been doing, we're really talking about climate change adaptation. So I just wanted to make that distinction. So in terms of an agenda for the next few slides. So I'll just give a brief overview of the project that we've been working on, or the projects, I guess, that we've been working on with Hospitality Newfoundland and Labrador. I will dive into a summary of climate change that we're experiencing in Newfoundland and Labrador, some of the impacts that the marine tourism sector might face as a result of climate change. And then I'll talk about some of the different tools that we've been working on for learning and development or risk assessment that will be sort of available for operators to use as a resource, and then just some next steps on continuing work and work that we have ongoing. So first up, just a project overview. So as we said a couple of times, really the root of this project is to make sure that the tourism industry remains resilient in the face of climate change. And one way we can do that is increasing the awareness regarding the impacts of climate change on the tourism industry in the province. So that's really the main objective of this project and the work we've been doing. So some of the outcomes that I'll talk about throughout the presentation. Basically, what we wanted to do was summarize relevant climate change projections for the province that are relevant for the marine tourism industry. We've also been looking at doing similar studies for the winter tourism industry and the outfitting industry as well. So we've got all kinds of climate change projections relevant to those different sectors. And then, like I said, we've been looking at impacts to the industry sectors because of those climate changes. And we've done that through both research as well as stakeholder engagement. So it's likely that we have talked to some of the people on the call today and kind of gotten their input on some of the changes that they've been seeing or experiencing or have impacted their businesses as a result of climate change. And then another one of the main outcomes was to create sort of tools that summarize all the information that we've collected for just learning and knowledge development. So different sorts of resources that we've put together that are going to be used to disseminate information related to climate change and impacts and risk assessment. So I will just dive right into the climate change projections. So we have a few different projections here that we're going to talk about, or a few different parameters, I guess, that we're going to talk about. So temperature, precipitation, wind and storms, a few different coastal parameters, so sea level rise, coastal erosion, those types of things. Oceanographic related to water quality, as well as terrestrial environment, that's things like river and environments. So I'll summarize some of those projections for the province. It'll be a pretty high level overview, but the projections are for sort of the mid-century to late century time horizons. So that's really from sort of around like the 2040s to 2100s, some of the changes that we'll be seeing throughout those different periods. And I just want to point out that the information, most of the projections that we have summarized are from pre-existing sources. So we didn't necessarily do all these projections ourselves. We do that work, but for this project, Newfoundland, both the government and MUN and other organizations have done a lot of really great work related to climate change projections. So there's a lot of available information already available. So we sort of summarize a lot of that information as it relates to this project. But in general, Newfoundland and Labrador is expected to become warmer, wetter, and stormier with climate change. Those are the three main things that we're going to be seeing. Newfoundland has this really interesting sort of climate scenario where we have the cold Labrador current coming down from the north, as well as the Gulf Stream coming up from the south, sort of mixing off the coast of the province. And it creates this very unique climate situation. And it also makes our climate very high in natural variability. So when we look at climate change projections, we tend to look at these sort of 30-year time periods where you can really see big trends in climate change. But because our climate is also, like I said, high in natural variability, there may be a year here and there where things don't seem to fit with that long-term projection. But that's, like I said, it's just the natural variability of the climate here. But really, when we're talking about projections, we're looking at longer term, sort of 30-year time periods that show those projections well and the trends well. So to dive into it. Okay. So first up, we'll talk about temperature. So there are a few different parameters we talk about here. First, we'll talk about averages and extremes. So essentially what we're going to see is an increase in daily average temperatures, daytime high temperatures, nighttime low temperatures, as well as warm extremes. So basically increases in temperatures across the board, whether it be average temperature or even those days that right now we might only see, say, a few days a year that are above 30 degrees, but those types of extremes are going to be increasing pretty much throughout all seasons. The largest increases are expected in the Labrador interior and at higher latitudes. And along with that, of course, cold extremes are decreasing in intensity and frequency. So if you look on the map over here, this sort of shows the projections for mid-century across all the seasons on the island portion of the province. These plots may not look that dramatic, but the scale here goes from about 3 degrees to 12 degrees. So, you know, in the summer months, we're looking at changes of somewhere around 4 degrees for the daily average temperatures, up to as much as sort of that 8-9 degree range as you get into more into Labrador. So those are pretty substantial changes that we're going to be seeing. And then when it comes to frost and freeze thaw, we're going to see a decrease in the number of days with frost, as well as a decrease in the number of freeze thaw cycles. And those changes will be particularly seen in regions or seasons that sort of hover around near freezing temperatures. So anywhere, say, that kind of hovers around the 0 degree mark, so in Labrador mostly, those areas are going to see fewer days with frost, fewer freeze thaw cycles than they're used to, as well as the shoulder season. So again, in sort of the spring months or the fall months, when the temperature kind of hovers around 0, we'll see less freeze thaw cycles and frost events than we do see now. All right, continuing with precipitation, we have some parameters related. I skipped over one. Starting with precipitation. When we talk about average precipitation, we're going to see increases in mean daily precipitation throughout most of the province by 2050, nearly the entire province by 2100, and that's pretty much across all seasons. Widespread increases expected across Newfoundland, with changes in Labrador typically being a bit smaller. In terms of precipitation intensity, there we're talking about events like the maximum 3-day, 5-day, or 10-day precipitation. So the amount of precipitation you see over those time periods, as well as events such as the number of days with greater than 10 millimeters of rain. Basically, we can expect to see an increase in intensity of those events throughout the century, and that will be particularly seen in Newfoundland, along the south coast and in the winter months. The plot over here shows the summer months, but again, you can see some of those changes are really concentrated down here around the south coast and in the interior in the summer. And of course, these changes will occur throughout mid-century and late century, but they will be the bigger changes in the late century. So continuing with precipitation, some snow parameters. Now I know marine tourism operations generally aren't happening in the winter, but snow parameters are still relevant in that there is infrastructure that still exists, of course, during the winter months that can be damaged by snow or freezing rain or anything like that. So it is still important to talk about. So in terms of snow, winter rain, and rain on snow, essentially what we can expect to see is a decrease in snow across the lower latitudes, so more southern Labrador, as well as the island portion of the province. And we'll actually see an increase in snow in the Torgat Mountains. And that's both in the amount of snow falling as well as snowpack density. And really what's happening there is as the atmosphere warms, it's able to hold more moisture. So in the lower latitudes, that moisture is falling as rain, whereas in the northern Labrador region, the temperatures are still quite low, so that moisture is still falling as snow. And we are also expecting to see an increase in rain falling on frozen ground and rain on snow. So that's any sort of winter rain event where you already might have snow on the ground and rain falling on top of that, which can cause issues with flooding and that type of thing. When we talk about freezing rain is an interesting one. So Newfoundland already experiences the highest amounts of freezing rain in all of North America. And that is projected to potentially increase with Eastern Newfoundland seeing the greatest total change. So Eastern Newfoundland, of course, already experiences a lot of freezing rain. And so we would continue to see the most freezing rain. And Labrador would experience the greatest relative change. So whereas Labrador might not experience a lot of freezing rain right now, they would see bigger relative changes there in the future. So getting to wind and storms, this is obviously one that's very relevant for the marine tourism industry. So when we're talking about things like hurricanes, nor'easters, it is expected that we would see a possible increase in the intensity of those tropical storm events or extratropical storm events, which would be primarily shown through increased precipitation rates during those events. So obviously they already bring a lot of rain with them, and that rainfall is supposed to increase during those events, again, related to the atmosphere being warmer and therefore holding more moisture. And then, of course, we would also see a potential increase in winds and storm surge that comes along with that during those storms. In terms of coastal parameters, so first up is sea level rise. I'm sure this is no surprise to anybody, but sea level rise is increasing both by mid-century and late century. By mid-century up to 0.4 meters, and then by late century up to a meter. So sea level rise is actually it'll increase different amounts in different regions of the province. I know that might not make sense because when you think of sea level rise, you think of sort of a uniform increase in sea level, but really what's happening there is the land is rebounding in the northern portion of the province. So in Labrador, during the last ice age, all that ice sheet was sort of weighing down the land. Since that has melted and retreated, the land is actually rebounding. So when you get sea level rise with that rebound, it's kind of changing together. So you don't feel the effects of sea level rise as much as you might on the island portion of the province where you're not getting that rebound. So that's sort of how it varies across the province. And with coastal erosion, again, highly variable across the province. That's largely due to different geology across the province. So most coastal erosion is happening or will happen in areas with unconsolidated cliffs and beaches. So that's sort of areas where the material is a lot looser than, say, sort of bedrock cliffs where you wouldn't see as much coastal erosion because the material is very consolidated. And really those increases in coastal erosion rates are due to changes in the processes that drive erosion, such as increases in wind and waves, or increases in groundwater flow or surface water flow, all things that contribute to coastal erosion. Next up is oceanographic parameters. So this is really relating to the seawater itself. So we can expect to see increases in ocean temperature, ocean stratification. So that's sort of the mixing between layers in the ocean, an increase in marine invasive species, a decrease in salinity, a decrease in pH, meaning the water is becoming more acidic, a decrease in nutrient supply, and also a decrease in sea ice and iceberg concentration. So all of those parameters have effects on the marine species that are, of course, living in our oceans. And we'll talk about some of those impacts in a bit, but they can cause changes in the quality of habitat and shifting species and things like that. And the last one, terrestrial environment. So this one might not be quite as applicable to the marine tourism industry since we're talking more inland here, but in terms of the riverine environment, we can expect to see an increase in wash-off or runoff events caused by extreme precipitation. So that's just more water flowing over the land and entering our rivers, causing things like erosion of the riverbanks. And it can also negatively impact the water quality, of course, as you're getting more water running over the land and entering the rivers. It's picking up, debris and chemicals and who knows what else, and sort of depositing that into the water, which can impact the water quality. And of course, we're also seeing an increase in water temperature in streams and rivers, which is impacting fish habitats and things like that. And then in terms of invasive species, pathogens, and pests, basically all the climate change conditions that we're talking about, it's going to alter suitable habitats and competition dynamics amongst species. So alter the sort of prey-predator relationships, things like that. And all of that is really conducive to making species more susceptible to invasive species, pathogens, pests, which can, of course, impact the health of the species overall. So that is pretty much everything related to climate change parameters. Like I said, that was a very high level review. There's lots of documentation out there available for specific regions of the province. But does anybody have any questions related to those parameters before I move on to the impact section?
Hi, Lindsay. I'm not seeing anything in the question and answer box or really the chat box, but we are having some issues with your audio. It comes and goes at certain points.
Sorry about that.
So I'm not seeing any questions, so I think you can continue.
All right, one sec. Are you still able to hear me there?
Yeah, I can hear you there, and but at times it kind of tails off.
Okay, I might, I'll see if that works. I'll just unplug my headphones and use my laptop speaker and see if that works a little bit better.
Yeah, it does sound a little clearer to me.
Okay, sorry about that. Okay, so we'll get into some of the actual impacts on the marine tourism sector. So we'll talk about the impacts in relation to those parameters that we just spoke about. So wind and storms, coastal, oceanographic and terrestrial environment, temperature and precipitation. So I'll just say again that the impacts that we sort of discussed were related. We got some of them through research, but most actually came from stakeholder engagement. So we talked to a lot of different operators throughout this this project and sort of talked about what things you're seeing, what things you might be concerned about related to climate change in the future. And we sort of summarized all of that together. So I'll go through some of that now. I'll say this is by no means an all-inclusive list of every impact that the marine tourism industry could face, but these are sort of the ones that we heard the most and saw the most in our research. So before we actually get into before we started characterizing impacts, I'll say we wanted to look at exactly what assets related to the marine tourism industry that might be impacted. So we wanted to characterize those assets to understand what we were analyzing. So these are sort of the few different categories of assets that we focused on. So first, the infrastructure, so things like wharves and docks, supporting buildings, like a ticket office or something like that. Coastal protection, breakwaters, armor stone, power and communications infrastructure, as well as water and sewer infrastructure. So all things, whether they be owned by municipality or the tourism operator themselves, that are sort of crucial to operating your business in terms of infrastructure. We also looked at transportation. So ferry and air transportation, as well as roadways and causeways. Again, not necessarily owned by the operator, but still fairly crucial in getting tourists to your businesses. And then in terms of species and environment, you may not typically think of species and environment as an asset in the traditional way. It's obviously not something anybody owns, but of course, aquatic species, marine birds, coastlines, habitats, all of these things are assets that are drawing tourists to the province and to your businesses. Similar with tourism experiences. So the marine sports themselves, boat tours, coastal destinations and trails, all assets that are bringing tourists to the province. And then we also talked about health and safety. So that's human health and safety, as well as insurance requirements and possible impacts to that as a result of health and safety or other impacts, and emergency planning and response. So all of those things are things that we talked about with operators to discuss some of the impacts that you're seeing or might see in the future. So first up, we can talk about wind and storms. So one of the main things we heard was really the impact that winds and storms is having on the actual bookings. So you're seeing increased cancellations, increased no-shows, or having to rebook tours. And that's both at the tourist or the operator level. So things like travel delays, during winds and storms, or blocked transportation routes because of downed trees or debris, flooding, washouts. All of those things might inhibit tourists from actually getting to your particular area of the province or to your business. So that's kind of at the tourist level. And then at the operator level, of course, where you're typically not going to be operating in wind and storm conditions due to safety reasons. And again, the wind and storms, of course, are going to have impacts on the health and safety of visitors. Of course, there are processes that you would have in place to not operate in those conditions, but even when it comes to things like coastal trails, tourists can sort of put themselves at risk and go out in unsafe conditions, which could impact certain organizations who manage trails or things like that. And then, of course, winds and storms would have impacts on the structural integrity of your facilities, as well as the aesthetics of your facilities. So damages to your buildings or your wharves, which of course relates to increased costs for maintenance and repairs. Winds and storms would bring, downed or damaged electrical and communication equipment. So again, that could be at the municipal level, but that might have direct implications for your business if you didn't have any sort of backup generator or something like that to keep things operating, especially if it was out for a long period of time. And like I said, any of these impacts, whether it be to health and safety or infrastructure damage, could increase sort of insurance premiums, which would of course be an increase in your operating costs. And then something that's a little bit less in our control, I guess, is the loss or damage of coastal habitats during wind and storm events. So there have been incidents where birds' nests and things like that have been damaged on the sides of cliffs. And of course, that's what everyone is coming to see. So if those are damaged, it's kind of putting a bit of a damper on the actual tourist attraction itself in some cases. So those are the things we heard loudest when it came to wind and storms. In relation to coastal parameters, so sea level rise, storm surge, which again is a bit of crossover with wind and storms, and then coastal erosion. The main things we're seeing there is infrastructure damage, so damage to wharves, buildings, docked boats or other marine vehicles during storm surge, increased damage or loss of coastal protection, so that's breakwater and armor stone, and then of course leading to increased maintenance and repair costs if you have to fix any of those damages, as well as you may see some damage or cleanup requirements related to any sort of debris that's deposited, say, on a parking lot or outside of your building or something like that. That can sometimes be pretty significant and cause quite a mess to clean up. And one of the other impacts is, of course, the long-term suitability of your infrastructure under these conditions. So as sea level rise is changing, is increasing, wharves or buildings may not be constructed to an appropriate elevation that would sort of maintain its resilience when it comes to sea level rise over time. So you could see some flooding or damage to that infrastructure as a result of that sea level rise or wave action, as well as flood damage, undermining or washouts to roads or other transportation routes. So again, that brings it back to tourists actually being able to get to your businesses. And again, loss or damage to coastal habitats from either increasing sea level or wave action. So similar thing, there's not so much control over there, but that is of course happening as waves and sea level rise become intensified. We're seeing some areas that are becoming damaged that were not necessarily damaged before, which could impact sort of where you operate, how you operate, things like that. Okay, so next up is temperature. So I guess typically you may not often think of temperature as an impact to your marine tourism business, but there are certainly impacts that are worth considering. So like I said, right now, we may not see too many days where we're seeing extreme heat or heat waves, so days above, say, 30 degrees, but that is projected to increase. So that could cause some sort of, for actual tourists, it could, exposing them to those events, you may see things like heat stroke and things that might just impact the health and safety of your tourists, and you may have to consider in your operating plans or your health and safety plans going forward. As well as if you have any sort of building infrastructure with increasing temperatures, we will see increased operating costs for cooling requirements in buildings. So you may need to use your air conditioning more, which could really drive up electricity bills. And also temperature can cause increased weathering to sort of wharves, roads, or other transportation infrastructure that has any sort of concrete or asphalt surface. Due to freeze thaw. So what's happening there is, water is getting in cracks and it's then expanding and contracting with freeze thaw and causing just weathering to your infrastructure. And then when we talk about precipitation, we are expected to see increases in precipitation, as I said earlier. That can have impacts on the actual quality of the tourist experience. So if you're forced to sort of operate in precipitation events, there could be implications there for just general enjoyment of tourism experiences. With some of those precipitation intensity events that I spoke about, we could get some structural or aesthetic damage to your facilities. Again, increasing maintenance costs, repair costs, insurance costs. Same thing with flood damage to roads and transportation routes, inhibiting tourists from getting to your businesses. There could be potential for sewer storm system backup at the municipal level, which could impact your infrastructure. And then another thing to consider is that in some locations, runoff could lead to decreased water quality offshore, which could result in things like poor subsurface visibility. So if you were to operate some sort of like a kayaking business or something like that, where it's really, nice for tourists to be able to see through the water down to the bottom, some of that could be impacted as these heavy precipitation events cause more runoff. And then lastly, related to the oceanographic and terrestrial environment. So increased temperatures, ocean temperatures, it's essentially causing increased stress on native species, which is slowing their productivity and reproduction rates. So that could impact, say, quotas, or just the frequency of interaction with species. We're seeing the northern migration of invasive species and as well as native species. So with increasing temperatures, we're seeing more species that are coming up from the south, which are considered invasive species. So things like the green crab, for example, which we've seen the last few years, as well as native species shifting more north up towards, the northern latitudes in Labrador. And we will see more of that in the future as temperatures continue to increase. With the introduction of invasive species, there's going to be changes in sort of prey distribution and food competition among species, which again puts more stress on those species. And therefore increases their susceptibility to disease and pests. And then water temperature and quality will impact the species habitat in general. And then sort of off on a different track, we are expected to see a reduced number of icebergs in the long term, which is, of course, important to many tourism operations. So those are the sort of loudest things that came out when we talked about impacts to those different, related to those different climate projections. So I don't know if there's any questions or anything anybody wants to add there before I move on to some of the, how we worked some of that into sort of tools and things like that for educational materials.
There's just one question there, Lindsay, in the chat window from Kim. Where do you find the information on the specific regions of the province? And that went back to the earlier section.
So there are a number of different resources on the actual province website, through the Department of Environment and Climate Change. There were some studies done through MUN that really detail all the different projections for different regions of the province. There's things related to rainfall, very specific to different rainfall stations in the province. So that would mostly be summarized on the government website. There are a ton of different resources there that I would encourage you to look through. There's also a number of studies that have been done by MUN, and most of them were sort of referenced on the slides that I went through. So those would, you could go look up those studies and find that information there as well. And then most of the information that exists right now is for more like temperature, precipitation parameters. And then we are doing some work that I'll speak to a bit later related to some of the winter projections. And that will be coming out relatively soon as well. But afterwards, if I can also email out some resources or something like that if anybody wants to contact me directly for that type of information. But I would reference you definitely to the government website.
Thank you.
Great. Okay, so if there are no more questions, so like I said earlier, one of the main sort of outcomes of this project was to develop different tools that tourist operators could use either as reference materials or use as a way to assess their own risks as a result of climate change. So just a few of the tools listed here. So basically all of those climate change projections that I just went to, we summarize them in like a 2-page sort of infographic document that will be made available. And that's just a very high level summary of those key climate change projections. And then anything related to the sector specific impacts. So in this case related to marine tourism, but we also have ones for winter tourism and outfitting. We summarized all those impacts as well into similar 2-page type infographics that can be used just for easily referencing and disseminating information. And then we also looked at some case studies where adaptation was done to support the tourism industry. So again, we sort of summarized some of those case studies into again, these 2-page infographics that can be used for easy reference. So those are some of the reference materials that will be sort of rolled out after this project is wrapped up. But one of the big ones that I'll speak to a little bit more is the risk assessment tool for operators that we created. So as Craig spoke to a little bit earlier, sort of my main job is I conduct these climate change risk assessments for a bunch of different clients, whether it be private industry or government or municipalities or what have you. And so there are a ton of different methodologies that you can use to assess those climate change risks on infrastructure, processes, and operations. And what we did was we essentially took principles from those different methodologies and wrapped them up into this sort of 5-step tool to help operators consider their specific dynamics of their businesses in relation to climate change, and again, specific to their region and the province. And this is really meant for operators who want to better understand climate change and proactively incorporate climate resilience into their operations. So really the purpose of this is to be able to identify your highest priority risks, and so that you can better plan for adaptation, or maybe you can sort of direct your investment in the right area to make sure your infrastructure is resilient in the face of climate change. So I'll talk through that a little bit. Before I get into the 5 steps, I'll just speak a little bit to the key concepts of risk assessment. So risk can sort of be described as basically the product of the likelihood of, in this case, a climate event occurring times the severity of the consequences if that event were to occur. So again, the likelihood is the probability that a climate event or climate change will occur. And we quantify that on this 1 to 5 scale. The 1 to 5 scale represents the change that's happening in that parameter. So if you're talking about something like a 10 millimeter rainfall event, maybe right now we're only seeing that sort of infrequently. So it's around a score of a 2. In the future, maybe we're projected to see that that type of event occurring a lot more frequently. So maybe that score would raise to a 5. And that sort of change in scores represents the change in that parameter over time. And then similarly, severity is the impact that that particular climate event or climate change would have on an asset, assuming that it did happen. So if you were to get a 10 millimeter rainfall event or more, what impact might that have on your infrastructure or any other assets that are crucial to your business? So maybe you have infrastructure that's very sensitive to rainfall. In that case, you might be looking at a higher severity score. So a higher score meaning that there would be a bigger impact, or maybe it's no big deal at all. You get 10 millimeter rainfall events frequently, and they don't do anything really to any of your assets. So you could score that sort of a 1. So I'll get into how we score those and how the tool can be used to score those a little bit. But I just wanted to give those sort of overall principles of risk assessment first. So again, you would just multiply your likelihood score by your severity score, and you land somewhere on this heat map, and a higher risk score would represent an item that is a higher risk, therefore a higher priority for adaptation. So like I said, there are 5 steps in this tool. First step is step 1, background data collection, fairly straightforward. Basically, the goal here is to create an inventory of your assets that are key to your operation. So things like your wharfs, your ticket offices, parking lots, or it could be a sort of a non-physical asset. So for example, any operating plans, health and safety plans, things like that, anything that could be impacted by climate change in some way, or it is vulnerable to climate change in some way. And again, it doesn't have to be physical in that your operating plans could be vulnerable to climate change in that they might be sensitive to a particular climate parameter, and therefore you might have to change them or adapt them because of climate change. So like I said, the goal here is basically to create this asset inventory and characterize your assets. So the tool sort of walks you through what assets should be considered, how to characterize them so that you can assess risk. And there are sort of worksheets throughout the tool where you can sort of tabulate all your information and keep it all in one place. So in this case, you'll see this sort of risk matrix a fair bit throughout the next few slides. But essentially you would tabulate your asset list in these first 2 columns here. So your asset and then any information related to your asset in this sort of comments column. And that's sort of forms the scope or the basis for your risk assessment. And then the climate parameters, which I'll get into in a minute, would go across the top. So that's step 1, just creating that asset list and characterizing your assets. Step 2 is to identify climate asset interactions. So within the tool, there's not really any sort of, there's no need really for anybody to have a background in climate change or to understand climate change projections thoroughly to be able to use this tool. It's meant for people who don't have any sort of climate background. So the tool includes 5 key parameters related to the marine tourism industry, 5 key climate change parameters that you would list across the top of this risk matrix here. So temperature, extreme winds and storms, sea level rise, and there's more. It's just would not fit here. So again, you would list those across the top and you would list your assets down the side. And then a climate asset interaction is essentially identifying which of these climate parameters affect which of these assets. So you can go through each sort of block and say, okay, does temperature impact my wharf? Probably not. So that's not an interaction. Does temperature impact my ticket office? maybe in terms of the financial implications of increasing temperatures and energy costs. So you could mark that one off as an X, and that's an interaction. And so you could do that with each one of these, and then anything with an X would be the ones that sort of move forward in the assessment. Anything that doesn't have an interaction wouldn't necessarily move forward because it's implied that there's no risk there. And I just want to point out that impacts can be sort of physical, operational, financial. There's a number of ways impacts can be characterized, but so we're not just talking about physical damage or anything like that when it comes to climate change impacts. So that is step 2, identifying the climate change interactions, or climate asset interactions, sorry. And then step 3 is where you get into actually characterizing the climate change. So this is the likelihood score that I spoke to earlier. And I just want to point out that this sort of high-level overview of this tool isn't necessarily supposed to be a tutorial on how to use the tool. It's more just information so that you know what's available, what resources are available out there. But when it comes to likelihood scoring, like I said, climate change projections are provided within the tool for these 5 key parameters that we identified. So essentially, there are all of these different plots and tables and things like that within the tool where you can go in and collect your likelihood scores based on your region of the province. So for example, this map here is related to coastal flooding and sea level rise. So if you were operating somewhere on the south coast, you could go to these maps and you could pick out your likelihood scores for the different time periods. So 2050s, mid-century, you have your relative score here of 2, and then in by late century, you would have a score of, I believe that's 4. So that just sort of, it gives you resources, so you wouldn't have to conduct any sort of climate change projections yourself. All the information is there for you to get your scores and input them into the risk assessment. So hopefully that makes sense. And then the way that works is within your risk matrix, you would have these sort of boxes here where you would fill out your likelihood scores. So there's a likelihood score for the baseline period, which represents a particular climate parameter right now. Then there's the mid-century, which is the period between 2041 and 2070, and then late century 2070 to 2100. So you can see the change in that parameter over time, which helps you identify risk, not only just as a whole in the future, but different time periods in the future. So short-term and long-term risks.
Lindsay, you keep dropping out at certain periods, and I hope it's not at the most critical time that you do. And I can't tell you what to do to fix it. So I don't know if it's intermittent or if there's a cause and effect there, but I did want to let you know that you do keep dropping out.
Oh, I'm so sorry. Is it for like long periods of time?
No, it's usually when you're getting ready to finish a sentence. So I'm hoping you're not giving the caramel secret as you're ending the sentence because we kind of lose you. But
I'm so sorry.
I just wanted to make you aware again.
Okay. All right. I'll try and speak slowly and clearly so that hopefully everything comes across. But essentially, like I was saying there, you would tabulate your likelihood scores within this risk matrix. So likelihood scores related to each climate parameter, you can tabulate them within the box that represents a particular climate asset interaction. So like I said before, for anything that wouldn't necessarily have an interaction, for example, temperature on your wharf, you wouldn't need to collect anything there because we determined already that was sort of screened out that there's no risk there. But for anything where there was a climate asset interaction, you would collect your likelihood scores and input them into the matrix here for the 3 different time periods in this assessment. And again, the higher the relative score, basically the greater change that we're expecting to see in that climate parameter over time. So then step 4 is where you get into the severity scoring aspect. So basically, like I said before, the severity scoring represents the impact that a particular climate parameter would have on your asset, assuming that that climate change or climate event, so it could be an extreme storm event or a rainfall event, if that happens, what impact does that have on the asset you're looking at? So in this case, we would look at what impact would extreme winds and storms have on your wharf, for example. So again, this is scored on a 1 to 5 scale. And within the tool, there's sort of descriptions for what that 1 to 5 scale means. And there's also a 0 here, which just again represents no interaction. But a score of 1 being something that doesn't really cause any damage, doesn't cause any disruption to your operations, isn't a big financial burden. Whereas a 5 would be, or a 4 or a 5 would be sort of a major impact that would potentially be a big financial concern, a health and safety concern. All of that information is in the tool that helps you decide what severity score is appropriate for that particular interaction. And then you assign that severity score with just one severity score that represents all time horizons in that case. So again, it's just assuming that this event does happen. What do the impacts look like? And you can you assign it a 1 to 5 score, and then you multiply those two scores together to get your overall risk. So like I said before, likelihood scores times severity score is what gives you your overall risk. You land somewhere on this heat map. The sort of green squares or rectangles represent lower risk items, so things that wouldn't necessarily be high priority for adaptation, whereas the red scores would be a much higher priority for adaptation. And that's basically what you would end up with. You would end up with a matrix with all of these different climate asset interactions, a bunch of different scores. You can see sort of where your biggest risk scores are, what time period it's in. So maybe it's in the mid-century, maybe it's in the late century, so you don't have to worry about it right away. But really, this can be used as sort of a planning tool for understanding where you need to focus your climate change adaptation efforts, your investments, and also when you should focus on those things. So, for example, if you knew you were going to be building a new piece of infrastructure in the next several years, you could kind of look at your sea level rise projections and see what impact that might have on the elevation, whatever elevation that you were going to build your wharf to, and you could kind of see if it was going to be a sea level rise would be an issue sort of in the mid-century or the late century, and that could kind of help you decide whether or not you need to raise the elevation of your infrastructure or something like that. So like I said, just in summary, this tool is really just a tool for understanding your highest priority risks for incorporating climate change adaptations, not only to understand the highest risks, but to understand the timelines when those risks would become apparent. And it's to be used for planning for adaptation. So from that tool, you might any number of different, interactions could come out as high risk. So you might look at things like incorporating sea level rise into your infrastructure design, selecting more resilient materials that would stand up better in the face of extreme precipitation or extreme storms. Maybe you would want to look at, where you place your infrastructure or where you conduct your boat tours or the locations that you go to. There's also cases for, communicating with municipalities to make sure that infrastructure is appropriate for operations in the case where municipalities own the infrastructure. We've also talked to some operators who have done data collection programs in cooperation with different research organizations. So something like DFO, where they've collected data about different marine species, and then that helps with, preservation of those species. And then we've also spoken to operators who have incorporated different technologies into their operations. So whether it be in their booking systems, helping tourists, book easier, cancel easier, rebook more easily if there was some sort of disruption, or things related to weather forecasting, so you can give your your visitors sort of a heads up on if a tour might be canceled or something like that with more precise weather tools. And then of course, diversification of services. All of these things can sort of be thought about or conceptualized based on the results of the risk assessment outcomes, depending on what your highest priority items are. So that's basically everything. That kind of summarizes the work that we've been doing over the last year. There's a few other projects that we currently have underway. So we are speaking to a few different operators about these hypothetical cost benefit analysis that we are doing, just sort of to highlight the business case for incorporating climate change into your businesses. So we're doing, like I said, hypothetical case studies that just show the importance and the benefit of actually incorporating some of these adaptation measures. So whether it be raising infrastructure or increasing coastal protection, things like that. So all of that, again, will be sort of wrapped up into these 1 or 2 page PDF summaries that will be used for disseminating information. And then, like I said earlier, our team is also conducting regional projections for a lot of the winter parameters. That will be sort of packaged up in a similar way and give really good projections for winter parameters throughout different regions of the province. And then of course, all of these tools are going to be rolled out eventually by Hospitality Newfoundland and Labrador. And that is everything. Hopefully you guys got most of that. I'm very sorry for cutting out. I'm not really sure what's going on there. I did get a new computer recently, so maybe the kinks aren't all worked out there. But yeah, is there any questions or comments or anything anyone wants to chat about, discuss?
I'm not seeing anything posted there right now, Lindsay. Perhaps though, one of the follow-up pieces, you had some resources. I don't know if we can feed that back through to the entire group. You know, if
Yeah.
you were to share it with us in the office, we could see that everybody there gets it, and that might be an efficient way to deal with that.
Yeah, no problem. Absolutely.
We'll just give another shout out to ask people if there is anything they have on their minds. You know, this is a wonderful piece of work, and I think thank you, Sheena. I think the you know, the timing of this, people are probably focused now on restarting their business, and you know, that's an important consideration for us right now. What is great though is that we can capture this stuff in a video. We'll be able to repurpose this stuff and make sure people have it and understand it as they're making their plans. So Lindsay, thank you very much. It is a great presentation and it is valuable information for our industry. Our next session with you is going to be on May 24th, and it's going to focus on the outfitting business. So be sure, everybody, to stay tuned to your email, social media, and you know, you can register at hnl.ca. Also, if you're looking around and see somebody who you think should have been on this conversation, remind them or let them know that these conversations are happening, and we'll certainly be happy to facilitate that. Again, thanks to our partners for their collaboration and support on this initiative: Natural Resources Canada, the Department of Environment and Climate Change, and the Department of Tourism, Culture, Arts and Recreation. Thank you everyone for joining us today, and I hope you enjoy the rest of your long weekend. Take care. Bye-bye.
Thank you. Bye.